In the previous lecture, we looked at the Coulomb's law, which tells us the electric force between 2-point charges. We look at the force in terms of magnitude and direction. Now let's look at this example. In the Bohr model of the hydrogen atom, the electron is imagined to move in a circular orbit about a stationary proton. This orbit results from the electric force of attraction between the electron and the proton. The radius of the electron's orbit is 5.3 times 10 to the power of negative 11 meters, and its mass is 9.11 times 10 to the power of negative 31 kilograms. We want to find the electron's speed, and in part B, we are going to compare the magnitudes of the electric and gravitational forces between the particles. You can pause the video here and try to do the problem by yourself. Then you can check your answer by continuing watching the video. From the problem, the radius of the circle and mass of electron are given. In part A, we want to find the speed of electron. We should note that the force that is keeping the electron moving in circular orbit is the electric force. So in this case, the electric force is the centripetal force that keeps the object moving in circle. So the centripetal force is the electric force. And this force is always pointing toward the center. Now let's focus on the magnitude of the force. Let's start with the electric force. So we use Coulomb's law. We know the magnitude of electric force is Coulomb's constant times the product of the magnitude of the charges. So we have magnitude of Q1, which is proton, times magnitude of Q2, which is the electron, divided by the radius separated by the two charges, r squared. So this equals Coulomb's constant times magnitude of proton is positive E, and charge of the electron is negative E, then divided by r squared. So this equals Coulomb constant times E squared divided by r squared. How about the magnitude of the centripetal force? From your mechanics course, we know that it equals to mass times speed squared divided by r. So when we equate these two, we get Coulomb constant times E squared divided by r squared equals mv squared over r. We cancel out one of the radius on both sides, then we can isolate for the speed. And since we are looking for the speed, so we can ignore the negative sign. So this equals square root of Coulomb constant divided by mass times r times E. Then we substitute the numbers. Speed equals square root of k, which is 8.99 times 10 to the power of 9 divided by mass times r. They are given. Mass is 9.11 times 10 to the power of negative 11, and the radius is 5.3 times 10 to the power of negative 11. Then times E, which is 1.6 times 10 to the power of negative 19. And we get 2.18 times 10 to the power of 6. And the unit is meter per second. Now let's look at part B. We want to compare the electric force and the gravitational force between the two charges. We already got to the equation for the electric force from part A. The magnitude of the electric force is Coulomb constant times E squared divided by r squared. And we also know from our mechanics course, magnitude of gravitational force, which is the gravitational constant times the product of masses of the two objects. In this case would be mass of proton times mass of electron divided by distance separated by the two objects squared. Now let's compare their ratio. Let's do force of gravity divided by force of electron. Then we get gravitational constant times mass of proton times mass of electron divided by r squared, then divided by the electric force, which is r squared divided by Coulomb's constant times E squared. We can cancel out the r squared and we substitute the numbers. Gravitational constant is 6.67 times 10 to the power of negative 11. And mass of proton is 1.67 times 10 to the power of negative 27. And mass of electron is 9.11 times 10 to the power of negative 31. Then divided by the Coulomb's constant times E squared. Coulomb's constant is 8.99 times 10 to the power of 9, and E is 1.6 times 10 to the power of negative 19 and squared. And we get it is around 4 times 10 to the power of negative 40. So the gravitational force is this times smaller than the electric force. So for the rest of the examples in this lecture, for most of the cases, we are going to ignore the gravity force because it is almost negligible when we compare it to the electric force. And that is the end of the lecture. In the next lecture, let's talk about superposition of electric forces.